Suppose a company wants to introduce a new machine that will produce a rate of annual savings in dollars given by the function s prime of x, where x is the number of years of operations of the machine, while producing a rate of annual cost in dollars given by the function c prime of x. So what we have here are already rates of change. So look, this is the rate of savings, and this is the rate of cost. So if we want to determine first, part A, for how many years will it be profitable to use the new machines? How many years will it be profitable to use the new machine? So the first thing we want to do here is we want to set the savings equal to the cost, so, or the change in the savings, the rate of change of the savings. So that's 428 minus x squared equals x squared plus 18 over 7x. And to solve this, it's a quadratic equation. So you've got a square here and a square here. So you've got to get everything on one side. So I'm going to go ahead and subtract 428 and add x squared. So I'm going to add x squared, subtract 428. Now notice I'm doing the same thing on both sides, like you always do with equations. Now this side is now going to be 0 because 428 minus 428, negative x squared plus x squared, that's 0. So we get 2x squared plus 18 over 7x minus 428. Now obviously those are some pretty big numbers, and we don't want to deal with that fraction. So I'm going to go ahead and multiply everything by 7. So 0 equals, let's look, if you multiply this by 7, and this by 7, this by 7, and this by 7, I get 14x squared plus 18x, and then I need to get my calculator out here and do 7 times 428, and that gives me minus 2996. Now, I could use the quadratic formula to do this rather than try to factor with all those giant numbers. So remember what the quadratic formula is. X is equal to the opposite of b plus and minus the square root of b squared minus 4ac, and then all of that is divided by twice a. So our a is going to be 14, our b is going to be 18, and our c is going to be negative 2996. Now the numbers are big, but because we can use our calculator, it's not going to be that bad. So that's going to give me x is the opposite, or negative 18, plus and minus. This, when you have a square, there's always two answers, and that's what that plus minus does. The square root, now b is 18 squared, minus 4 times 14 times negative 2996. Now don't forget that negative sign or you'll miss this. Also, don't forget, all of this is going to be over twice. In our case, a is 14. So now it's just a matter of getting the numbers. Negative 18 plus or minus the square root, and I'm going to go ahead and find that number inside the radical. I'm just going to type it in just like that. I'm going to go 18 and hit the square key, minus 4 parentheses 14 close parentheses, parentheses negative 2996 close parentheses, and that gives me 168 100. Since I'm using my calculator, I don't even bother to do the order of operations. The calculator knows it. And all of that's over 28. So unless this comes out as a nice whole number, we're going to get decimals, and that's fine. I've got to take the square root of 168 100. Now, there are a couple ways to do that. You can go second x squared, or remember that the square root is a 1/2 power, so I'm just going to put exponent key 0.5. And that gives me exactly 410. And now that's divided by 28. Now, that's a nice number. That means we could have factored this, but I'm glad we didn't try it because it's just big numbers, really hard to factor. So I have two answers here. I have negative 18 plus 410 divided by 28. And I have negative 18 minus 410 divided by 28. The only thing you change is the plus and minus between them. Everything else stays the same. So that's a negative 18 plus 410, 392, divided by 28. And that comes out to exactly 14. Now this other one, negative 18 minus 410, is negative 428 divided by 28. And that comes out to negative 15. And I'm going to round it to 3 places because it's not exact. 0.286. So now we have these two choices to look at. Okay. Now, remember that x is the number of years. Look, we're looking for how many years. So a negative answer here doesn't make any sense. So we're going to throw it out. And so our answer to part A is this machine is going to be profitable for 14 years. So throw out the negative one in this case because x stands for times and it doesn't make sense. Time doesn't make sense here. Now we're supposed to find out part B. And part B is, what are the net total savings? What are the net total savings during the first year of use of the machine? So they're trying to find, not only do they know it'll be profitable for 14 years, they want to find out how much profit, and they want to look at the first year. So this time we're going to need integration, okay? Because we want to know a sum of all during that first year. So it's going to be an integral, a to b. This is the fundamental theorem of calculus, of f of x minus g of x, because we've got two functions here, cost and savings, dx. And remember, f of x is the greater function, that is the function on top. So we'll have to figure out which one of these functions go on top. Okay. Now we only want to do the first year, so it's from time 0 to 1. Okay, so we know that part. But we have to figure out which one of these functions, f of x or g of x, and that's our two functions up here. 428 minus x squared. Let me write them here. 428 minus x squared. That is our change in our savings over time. And this is our cost. And notice those derivatives mean that it's the rate of change of the cost. So x squared plus 18 over 7x. So we want to know between 0 and 1, which one of these is higher. Okay, these are both quadratics. Okay, this one is a quadratic that's upside down because it's got a negative in front of the x squared. And this one's a quadratic that's right side up. So imagine it's looking something like this, okay? And we want to see which one of these is the top. What's on top, what's on bottom at time 1. And so we just need to figure out which one of these is the higher or the bigger function between 0 and 1. So I'm going to pick a number between 0 and 1, like a half, and I'll put the decimal form. It'll be a lot easier. And evaluate each one of these, and whichever one has the bigger result is the one that we put first in our integral. So this is 0.5 squared. And then the cost, the change in the cost at 0.5 is going to be 0.5 squared plus 18 over 7 times 0.5. And I'm just going to use my calculator to do both of these. So 428 minus 0.5 squared is 427.75. And 0.5 squared plus 18 fraction key 7 parentheses 0.5 is 1.536. So clearly, a greater function is this one. So the 428, it may need a little bit more space, so I'm going to stretch this out a little bit. So my first function is 428 minus x squared minus x squared plus 18 over 7x. So that's going to give me the integral from 0 to 1. And I'm just going to go ahead and simplify everything in here. 428 minus x squared minus x squared minus 18 over 7x dx. And then combine like terms. 428 minus 2x squared minus 18 over 7x dx. I'm ready to take the integral of this. So using the exponent rule, that's going to be 428x to the 1 divided by 1, right? We add 1 to the exponent. There is no exponent. Minus 2x to the third divided by 3 minus 18x squared over 7 divided by 2. So just do the times 2 in the denominator. Now this whole thing is going to be evaluated at 0 and at 1. So that's going to be 428x minus 2/3 x cubed minus 18 over 14x, which would reduce, but you're just going to do it on your calculator, so you could just leave it. 0 and 1. Now, we evaluate it first at 1. 428 times 1 minus 2/3 times 1 cubed minus 18 over 14 times 1. And now we're supposed to subtract from that what we get when we put 0, but look, 428 times 0 is going to be 0. 2/3 times 0 cubed is going to be 0. Minus 18 over 14 times 0 is going to be 0. So this whole thing is 0. So I just need to do 428 minus 2 fraction key 3 minus 18 fraction key 14, and I get 426 and 1/21. So it's about $426. So the net total savings during the first year of use of the machine is $426. Okay. Now the last part says, part C. So the last part is, what are the total net savings over the entire period of use of the machine? So remember, we already found out that it produces savings for 14 years. So it's going to be the same thing, but from 0 to 14 this time. So it's going to be the integral from 0 to 14 of f of x minus g of x, which we already found, 428 minus 2x squared minus 18 over 7x dx. And really, we'd already done the integral, so we could have just used that, remember? 428x minus 2/3 x cubed minus 18 over 14 x squared, evaluated at 14 and 0. And we already know that because all terms have an x, that when we evaluate it at 0, it's just going to be 0, so we don't even have to do that part. So all we have to do is 428 times 14 minus 2/3 times 14 cubed minus 18 over 14 times 14 squared. And again, I'm just going to do the entire thing on my calculator. So I get 428 parentheses 14 minus 2 fraction key 3 parentheses 14 raised to the third power minus 18 fraction key 14 parentheses 14 squared, and I get 3910.667. So that's about $3,911. And that's the total savings over the entire use of the machine for 14 years.